Okay, I am now on explain number 3, modeling arithmetic sequences from a description. So this asks you to construct an explicit rule in function notation for the arithmetic sequence represented and use it to solve the problem. Okay, so the odometer in a car reads 34,240 on day 1, and every day the car is driven 57 miles. If this pattern continues, what would the odometer read on day 15? Okay, so you could do it the hard way and just add 57 for like however many times. But remember, we're using a rule to help us construct this. So the odometer reads 34,240 miles on day 1. Every day the car is driven 57 miles. So the value of the function, value 1 is 34,240. And the common difference is 57 because every day it increases by 57. So you can write an explicit rule in function notation, okay, and use it to find the mileage, or f of 15, on day 15. So we're just simply going to plug everything into the explicit rule. 34,240 is my day 1 mileage, so that's f of 1. 57 is the common difference because that's how much I'm adding to it each day. So f of 15 is going to be 34,240 plus 57 times 14 because it's 15 minus 1. All right, 57 times 14 is 798, and then adding that to the 34,240, you get 35,038 miles. All right, looking at number 7, Ruby signed up for a frequent flyer program. She receives 3,400 frequent flyer miles for the first round trip she takes and 1,200 frequent flyer miles for all additional round trips. How many frequent flyer miles will Ruby have after 5 round trips? All right, so we're going to construct an explicit rule in function notation and use it to solve the problem. So here we go. So from the problem, we know that the first value is 3,400, and it says that each trip after that she's going to rack up 1,200 more miles. So the common difference is going to be 1,200, so we put it in the explicit rule. We're going to find function value of when f is 5, 3,400 plus 1,200 times 5 minus 1, which is really 4. You get 3,400 plus 4,800, and that is going to be 8,200 miles that she will have after 5 round trips. All right, number 8 says a gym charges each member $100 for the first month, which includes a membership fee, and then $50 per month for each month after that. Okay, so f of 1 is going to be 100. And then each month after that is $50, so it's going to go up by 50, so that's your common difference. So using our explicit rule, here we go. How much money will they spend for 6 months? So f of 6 equals 100 plus 50. 6 minus 1. 6 minus 1 is 5. 5 times 50 is 250 plus 100. And they're going to spend $350 for 6 months at that gym. All right, I'm not going to go over all of the questions under elaborate, but number 9 is reasonable. What domain value usually makes sense for an arithmetic sequence model that represents a real-world situation? Well, honestly, the domain is the set of, term numbers or positions, so domain values that make sense are going to usually be positive integers. This is a real-world situation. Okay, at this point we're going to move into the evaluate homework and practice, and I will do a few for you, but we need to move to page 177, so please join me there.